Native developers, last week Numberphile published a mesmerizing video about trigonometry, and you're not gonna believe how easily some of these animations can be implemented in React Native. Let's have a look. Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, I would like us to rebuild some of the animations from last week's Numberphile video. And to drive all of the animations, we need one animation value that goes from 0 to 2 pi, so full revolution. And we're gonna use loop from Redash that gives us all the boilerplate we need to get an animation value that goes from 0 to 1. And the first parameter is the duration of the animation. We can choose, let's say, 3 seconds. And we can convert this animation that goes from 0 to 1 to go from 0 to 2 pi. So I can write theta, and we can use mix of progress. We go from 0 to 2 pi. And let's see if theta looks good. So I have a driver component, and we can pass it the theta value. So we can see if the circle rotates properly around the circle, and we need the radius of the circle. So let's go into driver. So we have radius and theta, which is an animated node. So these are our properties, radius, theta. So now we need to animate the circle based on theta. So we have the coordinates in polar coordinate system. So we have radius theta, and we need to convert these coordinates into coordinates in the Canva coordinate systems. And Redash provides us a function in order to do that. So we have xy equals polar to Canva. And these are our polar coordinates. And we need to give it the center. So I can write it here. Center is x radius, right? So where is the center in the Canva coordinate system? X is at radius and y is at radius here. So y is radius. So let's apply the transformation. Transform, translate x equals x, and translate y equals y. So now it rotates nicely, but of course there are two issues. First, we need to remove half of the width of the circle for radius, right? So here we're gonna remove, so the radius is 25, so the diameter is 50, so we remove half of it. Same for y. Now it's properly centered, but we have the boomerang effect. So when it goes to 1, it goes from 1 to 0. So we can disable the boomerang effect here. So now it should rotate nicely. So this is gonna drive all of our animations. So let's draw a line. And in the line, we're also gonna have a circle. And the circle is gonna match always the x coordinate of this rotating circle of driver. So here we just show driver to see that the animation value that drives everything is correct. And we can use it basically to do some debugging. So we're gonna have a line component. Guys, you're not gonna believe how easy some of these animations can be built. So we are gonna pass also this polar coordinate, right? The theta radius. So theta radius. So you see here, and this is the circle we want to animate to match always the x coordinate. So it's the same, right? We have the same properties. Oops. So we have radius and theta. And we also have the same x and y value. Now, what we want to do is to move this circle based on the x coordinate here. So transform is translate x of x, and I would do also minus radius of the small circle. Which is, so L radius. That looks good, I think. Let me add maybe some background color. So this point seems to match always the x coordinate of this circle. So this is where it gets interesting. We can add another line here. So here they're overlaid on top of each other, so you don't see anything. But what I can do is add maybe to theta, I can add 90 degrees. So that would be math.pi divided by 2. Okay. And what I can do also is to I'm going to add some rotation to the line. So I'm going to create a rotate property. The first line, the rotation is at 0. So I'm going to pass theta as parameter. And here I want to rotate. So I want a vertical line. So I'm going to do math pi divided by 2. So we have rotate. It's a number. So we get it here. We use it to rotate the line. So I'm going to do transform rotate. Perfect. And now to move the overlaid point across this axis, I'm simply going to add to theta the rotation. And I need to rotate also the container of the circle. So I can just add the transform here. Up. So you see now this point matches always the x coordinate of the rotating circle, and this one always matches the y coordinate. So now that we have a generic way to add lines, right? I can even add, let's say, math pi divided by 4 by 8. Let's make here the number of line generic. So we're going to create a variable called circles. And let's do first an array, I don't know, of 10 lines. So we need to do a fill 0 map as the value the index. And so now we need to divide, we need to create a delta angle. So what you want to do is to divide 2 pi. So what you want to do is to divide 2 pi by the number of lines. So you know by how much radians you need to increment. But of course, once you go more than 1 pi, you will have the same lines overlaid on top of each other, right? So let's say for an angle of pi divided by 4, this line, it's the same angle than 3/4 of 2 pi. So we're going to divide math pi by the number of circles. So circles.length. And now for each circle, so we have the index. We return a line. So the key is the index. And the rotation is index times delta. And you see how it looks like a circle rotating within a circle, even though we are just tracing lines. And these little circles, they only navigate within a straight line. And yet it feels like we're having a rotating circle. So here I have an array of, so we have 2 again. Here 19, can put 25. And here I have a list of colors, which I took from the video. And we can add color. So we can select from colors at index modulo colors times length. So here we get color as string. So background color is color. So here it is. On the circle, we can add some Z index. You see here, because so it goes over the lines. So Z index 100. And we can add also Z index to driver. But we use driver as a debugging tool, right? Here we can remove it. I do seem to have some sort of mistake here. And it's not L radius divided by 2, but L radius. And now it looks correct. What a cool animation, and what a great way to approach trigonometry. I really recommend you watch the original video from Numberphil. Now let's build another animation from the video, but with an SVG Canva this time, because then it's easier to animate some lines based on some coordinates and so on. So let's draw the circle. So here we have our driving animation value, and so we can also display the circle that shows the theta value. So we have a circle, and we have a stroke width. So center X is radius, center Y is radius, and radius is radius. Yes, we can add a fill of transparent. And we can center everything to the screen. So I'm going to add everything into a group. And in fact, I'm going to move these properties to the group and add a transform. So translate x0, y. I have a value here, padding top, perfect, which is just the height minus the radius, plus here the status bar height and the height of the header. So we have our circle. We can display the theta value. So I'm going to create an animated circle. Radius. So I have a smaller radius here. And Cx and Cy we get by converting here the polar coordinate to the Canva coordinate. Same than in the non-SVG example. So polar to Canva. So let me create center. Is radius, y radius. And so we have theta radius and the center. So Cx equals x, Cy equals y. And fill, let's say, cyan. So we have our theta value. Now let's write the x-axis and the y-axis. So we have line, x1 is at radius, y1 is at 0, and x2 is at radius, and y2 is at radius times 2. So that would give us the horizontal line, a vertical line, sorry. Let's do the horizontal one. x1 is at 0, y1 is at radius, y2 is at radius, and x2 is at radius times 2. Perfect. Now let's do the circle that represents the x and y coordinates of the driving value, and I'm gonna move this one to the top here. So let's do 2 other animated circles. So one represents the x-axis, so x is x, but Cy is radius. And here Cx is radius and y is y. Perfect. And let's use like different colors. Use, I don't know. Just some random colors. Looking good. And now let's do a line that is between these 2 points. So I'm gonna do an animated line. And so x1, y1 are gonna be these coordinates. And x2, y2 are gonna be these coordinates. So this is x1, y1. And this is x2, y2. So now we have the line in between, and let's draw the circle that is in between these 2 lines. So I'm gonna write another animated circle. I don't know. Okay. And now the coordinates should be where? So animated line. So should be the midpoint between these 2 values. So I think x minus radius divided by 2. Is that? So divide x minus radius divided by 2. And same for y. Nope. Actually think it's add radius divided by 2 and we divide also this one by 2. So we divide y by 2 divide should be good. Yes. So here we have the midpoint, and you see that the midpoint draws a circle, which we can also print, which should be radius divided by 2, I think. So you see, now if we only display these two, this circle and right, so I can remove these guys here. You just have the circle that rotates nicely within this circle. Guys, before wishing you a happy hacking, if you are interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user interactions in React Native that will run at 60 FPS even on low-end devices. And I started already to update the course with Reanimated 2 lessons. Reanimated 2 is currently in alpha, but if you want to get a sense of how this new API look like, I already published 5 lessons on the topic, and there are more to come in the upcoming weeks. So if you're interested to learn the fundamentals of gestures and animations, I hope that you will check it out at startreactnative.dev. Guys, I hope you enjoyed these trigonometric animations, even though we didn't use any trigonometry. The trigonometry was hidden with the polar to Canva coordinate. So we used trigonometry to convert a polar coordinate to a Canva coordinate. But I hope also that you will check out the video from Numberphil. Absolutely a great video about trigonometry. Guys, I'm looking forward to talk to you soon, and in the meantime, happy hacking.